Okay, today we're going to be talking about atoms and atomic theory. What does that mean? So the word atom comes from the Greek, and it was by a Greek person named Democritus, and he called them atomos in 530 BC, which means uncuttable or indivisible. So what is an atom? An atom is the smallest part of an element that maintains the characteristics of that element. So it's the smallest piece of gold that is still gold, or the smallest piece of oxygen that is still oxygen. So for example, if we took a gold ring, and hypothetically we were able to cut it in half and make two smaller pieces, and then we were able to take one of those pieces and cut it in half again and again, eventually we would end up with something that is extremely small, which would be one atom of gold. So if we were to cut that one atom of gold, we would no longer have gold. We would have the parts of that atom, which we call subatomic particles. So let's put atoms into perspective and how small they actually are. There are 7 octillion atoms in a 150-pound person. So let's look at the parts of an atom. So there are 3 basic parts of an atom: the proton, the neutron, and the electron. The nucleus is a dense cluster of protons and neutrons found in the center of the atom. So that's where our protons and our neutrons are hanging out. Our protons are the positively charged particle of an atom located in the nucleus. So they have a positive charge. So if you think proton, you think of the P. That'll help you remember that it's a positive charge. A neutron is the neutral charged particle of an atom located in the nucleus. Or you could say that it's a no charge. It's neither positive nor negative. So you can remember the N for neutron, neutron neutral, or neutron no charge, whichever helps you. And the last one is the electron. And the electron is the negatively charged particle of the atom that orbits the nucleus. So those electrons are circling that nucleus at a very high rate of speed. And those electrons create electricity. All atoms are made of these 3 basic parts. And what makes an atom of an element different from an atom of another element is the amount or the number of these parts, or subatomic particles. So an atom of oxygen is going to have, every atom of oxygen is going to have the same amount of protons. And if it had if it had more or less protons, it would be a different element. So let's compare them. So the size of them, of electrons and protons, are very different. It takes 1,836 electrons to have the same mass as one proton. So if an electron weighed the same as a dime, a proton would weigh the same as a gallon of milk. Neutrons and protons have almost the same mass. They're about the same size. And obviously electrons are much smaller. So let's try this on for size. So these are 2 examples of atoms, just depicted a little bit differently. And atoms are mostly made up of empty space. So in between this nucleus and these electron orbits is all empty space. So therefore, every object in the universe is made up of mostly empty space. How many protons does each atom have? So let's look at our periodic table, and we'll figure out how to read those. So this number here, this whole number, right, they go in order on your periodic table. That's the number of protons. We call that the atomic number. Over here, this number with a decimal point after it is the atomic mass. That's how much matter is in one atom of that element. So let's look at some examples. So we have helium has 2 protons and an atomic mass of 4. Titanium has 22 protons and an atomic mass of 47.88. Lead has 87 protons and an atomic mass of 207.2. Do you notice a pattern? The atomic mass is always greater, and usually it's about twice as large as the atomic number. So the protons are the fingerprint of the element. So just like we have fingerprints and no two people have the same fingerprints, each element has a number of protons, and no two elements have the same number of protons. And so it's the protons that determine which element the atom is. So let's look at how many protons an atom has and how we figure out neutrons and electrons. So the amount of protons equals the amount of electrons. And this is if the atom is neutrally charged. So generally speaking, we're going to assume that the atom is neutrally charged, which means the number of positive charges, so the number of protons, equals the number of negative charges, which is the number of electrons. So protons and neutrons equal each other, they cancel each other out, which makes it neutral. That doesn't always happen, but we're going to get into that more as we go. So protons give atoms their identity. Electrons give atoms their attitude. So if you have more protons than electrons, you're going to have a positively charged atom, okay, because there's more positive than negative. If you have more electrons than protons, you're going to have a negatively charged atom because you have more negative charges than positive charges. So how do we find the number of neutrons? We take our atomic mass and we round it, and then we subtract the atomic number. So for iron, we're going to take 56, which is our atomic mass. We're going to round it, and then we're going to subtract 26, which is our atomic number. So 56 minus 26 equals 30. So that's 30 neutrons. All right, so let's check how we understand this. To do that, I'm going to switch into this mode so that we can see better. So we have some different elements, and we're going to see how we do. So we've got lithium. How many protons does lithium have? So we're going to look at our periodic table. We see that it has a atomic number of 3. So it has 3 protons. And we know that if we have 3 protons, we're going to assume that it's a neutral atom, and it has 3 electrons. So how many neutrons does it have? So it has an atomic number of atomic mass of 6.9. So we're going to round that to 7. 7 minus 3 gives us 4. So we know that it has 4 neutrons. So I want you to pause the video right now and take a minute to do these other 4. Okay, let's see how you did. Okay, now remember to go to Edmodo and to do the quiz. Thank you.